Okay, so before the lesson, I'm going to tell you that today is one of those days where you're just like, what are we doing? Just hang in there, follow the steps as I go, trust me that it'll work, and that as you go through it and you go through examples, you'll be like, okay, I get it now. Okay? Try not to get overwhelmed by it. It's just another process, okay? To warm up, though, is we're going to convert to vertex form. If you don't have a blue sheet, yeah, go ahead and grab one. All right, so you're going to convert to vertex form. These two problems, right, we know how to do already, okay? Convert to vertex form. Well, we know vertex form. What is vertex form? You gave me intercept. It's a x minus h squared plus k, right? Yep. So that's what we're looking for. Now, to convert to vertex form, the way you've been taught so far, and you're going to learn a different way that's quicker today. That's what today's about. But the way you've been taught so far is find the pieces. What are the pieces? A, H, K. So that's our method. So that's what we're going to do. We want to find A, H, and K, right? So A, H, and K. Well, our A is given always, right? Our A is always in the original. It's in every equation, so we know it. What is our A here? It's just 1, because there's a little 1 out there, right? So our A is 1, right? Our H and our K come from what? The vertex. So we obviously need to find the vertex to find our H, K. Now, to find the vertex, you need a formula, and this is something you did need on the quiz, right? You needed to know this. The formula to find a vertex from standard form is, well, at least to find the x value, is negative b divided by 2 times a, right? That was the formula. Negative b divided by 2 times a. So we need to pull out our pieces and we need to find that. For us, that's x equals negative what? What's our b? Negative 2, right? Divided by 2 times 1, because that's our a. So that's positive 2 divided by 2, that's 1. So what did I just find? The x of my vertex, right? So I know I got 1 something, right? When I have 1 something, what do I do to find the other something? The y. You got to plug it in, right? So I'm going to say, okay, y equals 1 squared minus 2 times 1 minus 3. And I just do that math either in a calculator or I do it out. And if I did, I would find what? It's negative 4. Okay? So that's my h and that's my k. I have 1 and negative 4. Okay, so these are my pieces. I just have to plug them into that. So I say y equals, well, we'll see. See what happens. Y equals, and then what's my a? 1. If it's 1, do I need to write it? No. So I'm just going to write parentheses squared. What goes in the parentheses? X minus h. What's my h? 1. So I write x minus 1. And my k is? Negative 4. So plus negative 4 is just minus 4. And I've converted to vertex form. Okay? So I have good news for you. If you don't love that process, you will have another method for that today. The process is find your a, find your h, find your k. To find your h, you got to do negative b over 2a. You plug it back in to find your k. Then you plug it into the equation, and then you're good. Question?
It's more steps, but can you take that, turn it into intercept, and then in intercept you find your AOS, and then plug that into, and then find your...
Yeah, because we're going to have to do that now, right? So if you wanted to turn that into intercept form and then do all this, if you're more comfortable, you could. So there's actually, I guess, 3 ways to do it. But this is the way to do it from standard form straight to vertex. I'm going to give you another way today to do it from standard form straight to vertex. Okay? All right, so now if we want to do this in intercept form, well, we still need the same pieces. We still need our A, H, and K, right? So my A, my H, and my K are still needed, and I just need to find them from here. Now remember, our A is always given. What's the A in this situation? -1, right? Because there's a little negative out front of this equation, right? So we know we have -1 as our A. Now, we want to find our x of our vertex, right? We need our vertex, which is our HK.
Wouldn't it be PQ for a thing?
Yeah, and we're going to get there. But I'm just saying what we need to find, right? And in order to find that, we have to use an equation, right? Now, before we do that, let's talk about this form. We have this form, y equals a times x minus p, x minus q. Are we all done writing that? Can I zoom in here? Yeah, okay. So that's our form. And there's a formula to find the x of the vertex in this form, which is? Vertex. I'm trying to find my vertex, and there's a formula for it. P plus Q divided by 2. So x equals P plus Q divided by 2. Now, I guess that means I need to know what my P and my Q are. And this is where a lot of people get tripped up. What is my P? Positive 7. What is my Q? Positive 3. And if that's still tripping you up, right? There's two ways. You can remember, you always flip it. If it's -7 in there, your P is 7. The other thing to think about is this. Look at this situation. I have x minus p in my form, and then I have x minus 7 here. What became what? What's that? Don't even think about the negative. What did I highlight? What became what? P became 7. Right? It didn't become -7. The negatives were in both places. The only thing that happened is you took P and you made it 7. So P must be 7. Right? Here I had Q and then I had 3. Forget about the negatives for a second. Q becomes 3. That means Q is 3. Positive 3. Right? It has to be. If it was a negative, then it would be minus minus and it would become positive. Right? And that's the other situation. Right? So our P is 7, and our Q is 3. So now we plug them in. X equals 7 plus 3 divided by 2, which is 10 divided by 2, which is 5. So if we're thinking about our vertex, that is 5 something. How do you find that something? If you know your X and your vertex, how do you find your Y of your vertex? Okay, so that's would we find our Y by plugging it in? Okay, so we got Y equals negative X, well not X, 5 minus 7 times 5 minus 3, right? You can plug that in your calculator or you can do the work. Either way, you will get, anybody know? 4. So it's 4. So my vertex is 5, 4, meaning my H is 5, my K is 4. Now I have all my pieces, I just plug them in to get my vertex form. Okay? So my vertex form is y equals negative x minus 5 squared plus 4, and I've converted to vertex form. Okay? So that was the old way of doing things, right? There's going to be a new way, at least for standard form, okay? Any questions on the old way? Okay. All right, so let's talk for a moment about this thing called perfect squares, okay? So, perfect squares. Perfect squares. We have that word square. We use it a lot. Oh, this square, that square, right? It means to multiply by itself, right? But why the word square? Well, a perfect square, if you think about it, for instance, 7 times 7 is 49, right?
Yeah.
That's a perfect square. 49 is a perfect square. The 49 is a perfect square because its sides are 7 by 7 by 7 by 7. It's perfect all the way around. That's why we use the word square, right? It's a perfect square. So, thinking about trinomials, you can have a perfect square trinomial. Remember, a trinomial is 3 terms, right? You can have a perfect square trinomial if it can be expressed by something squared, right? So for instance, this trinomial, x squared plus 4x plus 4, can be expressed as x plus 2 squared. Therefore, it's a perfect square trinomial. Now, how can you know? Well, if we have x squared plus 4x plus 4, and we magic x'd it, right? We would put 4 at the top, 4 at the bottom, two numbers that multiply give me 4, add to give me 4? 2 and 2. So it becomes y equals x plus 2, which, of course, could be rewritten as x plus 2 squared, right? So it's a perfect square trinomial, right? Okay, so why does it matter? Well, knowing that something's a perfect square trinomial can be very helpful to us. What else has parentheses squared in it that we've been dealing with a lot, that our warm-up was about? Vertex form, right? So we're going to harness the knowledge of perfect squares to help us convert to vertex form in a quicker way, okay? So that's what today is about, okay? Now let's make sure we can identify perfect squares and we know what they are. So it says which trinomial below is a perfect square, and prove it. So have we all got a chance to do this yet? Okay, I'm going to give you a few minutes. You got to magic x both of these, and then tell me which one's a perfect square. If you did finish it, think about this question down here. What do you notice about these perfect square trinomials, meaning the numbers in them, and then the fact that it turned out to be a perfect square? See if you can find a rule that you can apply to all perfect square trinomials, okay? So go ahead, I'll give you some time to do that, okay? All right, so I'm going to start doing it up here. So if I magic x this first one, I would have 20 and 9. Two numbers that multiply 20, add to 9, that's 5 and 4. So this becomes y equals x plus 5, x plus 4, and that is not a perfect square. Right? This one over here, if you have 9 and minus 6, if you're multiplying to get a positive and you're adding to get a negative, they must both be negative. So two numbers that multiply to give me 9, add to give me 6, 3 and 3. So I end up with y equals x minus 3 times x minus 3, which is x minus 3 squared, right? So that is a perfect square. Right? Now, it says, what patterns do you notice? What do you notice about this one that it had going for it that this one did not? Leo, what do you notice?
For the second equation, both numbers are multiples of the same number.
Which is 3, which ended up in our final answer, right? Anything else we notice?
I don't know if it's wrong, but full limit must have like a GCF.
Well, it's not a GCF because you didn't divide everything by something.
Okay. But
Right.
what would it be?
A GCF is common to all things. This had 3, this had 3, but you couldn't divide that by 3. But there is a factor situation happening here. Anybody else notice anything? Okay, so let's come up with a situation here. If we were trying to find a perfect square, and we started with the b value, 6, how do you get from the b value of 6 to 9, but you can't add. So go from 6 to 9, but no adding and subtracting. What do you do? Take 6, do what, you get 9. Divided by 2, and then multiply by 3, which is 3 times 3, which is squaring it. Okay? So when you have a b value, and then you divide it by 2 and you square it, and you get your c value, that's a perfect square. Okay? So that is a formula that we want to know. Your c value equals b divided by 2 squared anytime you have a perfect square. Okay? You take your b, divide it by 2, square it, you have your c. Right? Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Right? And that's always going to be true with a perfect square trinomial. Okay? The other thing we want to notice is that the answer is always y equals x plus b divided by 2 squared. So think about our situation. X plus negative 6 divided by 2 squared. So that would be x plus negative 6 divided by 2 is negative 3. So x minus 3 squared. And that's always going to be the result of a perfect square trinomial. So why is this helpful? Well, if you can recognize it, you can skip right to this part. You can go right from here to here. You don't have to magic exit. You don't have to do anything. You just go boom, boom. Perfect square. Okay? Now, the other reason it's important is it's going to help us. This parentheses squared will help us convert to vertex form. That'll be on the next page. For now, let's practice using this. So let's try to find the missing b and c values here using these two formulas. Right? So b, you'll have to solve for. C, you just plug in b. Okay? So go ahead and try that. I'll give you a couple minutes. So here, there's another. If you want the b, if you're trying to find the b, obviously you'd have to solve for b here. So it would be b equals 2 times the square root of c. Right? That's your formula for b. Now, this is a fancy looking formula, but usually you can do it in your head. Right? If you think about it this way, this one we're trying to find b. Well, it's 2 times the square root of c. What's the square root of 16?
4.
What's 2 times that? 8. So this is 8x. Now, you could write it out. You say b equals 2 times the square root of 16. That's 2 times 4. That's 8. But if you get good at these, you can usually do them in your head. Right? Here, c equals b divided by 2 squared. Again, fancy looking formula. But what is b divided by 2? What is 5 squared? 25. So you see how you could do this pretty quickly if you get good at it, right? Again, if you want to plug it in, it would be c equals 10 divided by 2 squared, which is 5 squared, which is 25. Okay? Let's try to do this one just by looking at it. B divided by 2 squared. So negative 12 divided by 2 is? Negative 6 times negative 6 is? 36. And see how quickly I can make a perfect square trinomial? Right? Okay. So, why do we care? I know you ask yourself that all the time. All right. Why do we care? Because we want to use this to convert standard form to vertex form. So we're going y equals ax squared plus bx plus c, and we're trying to get to y equals a times x minus h squared plus k. And we're going to use completing the square, meaning perfect squares, in order to get there quickly. Now, the first time we go through it, it'll be slow, but once you get the process down, it's a lot quicker, okay? Now, this is the part where you might be like, what is he doing? Just hang in there. We're it'll make sense in the end. Okay? So we have the situation. We have this trinomial, and we want it to be in vertex form. Okay? The very first step that we do is we say, that c value is not a perfect square c value, so I'm kicking it out. So you kick out your c value and add parentheses. So notice that this, we added parentheses, I left the big space, and then I put +4 on the outside. I kicked it out. C value, no good, get out, right? So it would be x squared minus 6x, big space, parentheses, +4, okay? We're kicking out that c value. And we're focusing right here. And we're saying, well, this space right here, I wish it was a perfect square. Because if it was, I could turn it into something squared. So I say, okay, let's get a perfect square out of this. Let's change this equation. So in order to do that, I need to know what b divided by 2 is. So you calculate b divided by 2 squared. And again, this is not always something that you have to actually write out or whatever. Sometimes you can just do it in your head, right? Because if I look at this, well, what's b in the original? What's that divided by 2? What's that squared? 9. So that's what we got when we calculated it, right? B divided by 2 squared is 9. Okay. So what do we do with that? Well, notice these spaces get filled in. The first thing we do is we add it into those parentheses. We say, okay, we found it. Now we're going to make it +9 in here. We're going to add that into the space. But adding 9 to an equation changes the equation. You can't just add 9 to an equation. So what could we do to offset that? Subtract 9. And we do that there. Right? And now we haven't changed anything. We added 9, we minus 9, the net result is 0. I haven't really changed the equation. I just added some pieces that changed its form. Okay? Okay. So we add b divided by 2 squared inside and subtract outside. All right. Then we get this situation where we have +4 and -9 on the outside. What can we do with that? +4 minus 9. Can we combine those? Yeah, it becomes -5. So then we combine the outside numbers. Okay? Well, why did we do that? Because now we have x squared minus 6x plus 9 on the inside. We created a perfect square trinomial out of scratch, right? Which can be rewritten because it's a perfect square. So I can use magic x to turn it into this. X minus 3 times x minus 3. So you can either use magic x or write x minus b divided by 2 times x minus b divided by 2. Because look, -3 is the original b divided by 2. Okay? And then the last thing we do, well, if I have x minus 3 times x minus 3, I can bring that together. It becomes x minus 3 squared. So we rewrite it as parentheses squared. And now you have vertex form, right? That's in vertex form. Something parentheses squared and then a number on the outside. It's vertex form. So we converted it to vertex form. We didn't have to do -b over 2a and then plug it back in, find our a, plug all the pieces in. We just did this thing. Now, I know that seemed like, well, that was a lot. But if you get good at it, it goes pretty quick. Okay? Let's do an example. And then the last thing we'll do is talk about, well, what if a isn't 1? There's a little bit more to it with A isn't 1. Okay, so now that took a while because we went through all the steps and we wrote all the steps. But watch how quick this can go. Ready? What was my first step? Kick out the c. So x squared plus 4x, kick out the c, leave a space. What was my next step? What was it? Do b divided by 2 squared. What's b?
4.
What's 4 divided by 2? 2. What is 2 squared? 4. So I put plus 4 here, and I put minus 4 here. Right? We want to balance that out. All right. And then next we
Add
combine the negative 3 and the negative 4. So x squared plus 4x plus 4 minus 7. Now the very last thing I got to do is turn x squared plus 4x plus 4 into a perfect square. Right? So that becomes y equals x plus b divided by 2, which is 4 divided by 2, which is 2, squared minus 7, and I have vertex form. Right? If you get good at this, you practice it, it's a lot quicker and more efficient than the other way. Okay? That took us less than a minute. Our warm-up took us like 5 minutes. Right? Okay. Now, what if A isn't 1? It's just a little more complicated. Okay? There's like one extra step. Okay. So our first step is the same. Kick out your C. So no matter what, you're always kicking out your C first, right? In this case, I have y equals 2x squared plus 12x minus 4. So I would write y equals, parentheses, 2x squared plus 12x, leave a space, minus 4. Okay? That's my first step. Now the next step is different because of that 2. I need to pull the 2 out because I can never get a perfect square if my A isn't 1. So I'm going to factor out my GCF. So what does that look like? Well, y equals, and by the way, the GCF is always going to be A, right? Just divide everything by A, right? So 2 outside the parentheses, and then I have x squared plus 6x, leave a space, and then minus what? Who thinks 2 and who thinks 4?
4.
Why 4?
It's not in the parentheses.
It's not in the parentheses. You don't divide that last number. We're not factoring that out. We're only factoring out of the parentheses, right? The 2 is being pulled out of the parentheses. The 4 was on the outside. So it stays the way it is. Okay. Our next step is we got to find b divided by 2 squared. Okay? So y equals 2 times x squared plus 6x minus 4. So add in b divided by 2 squared. So what is b?
6 divided by 2 is
3.
9.
3 squared is 9. So I'm going to add 9. Now, this is a tricky part. I just added 9 into this equation. But how much value did I add to this equation?
9,
18.
18. Oh, yeah. The 2 outside.
It's 2 times 9. I put a 9 in here, but there was a 2 on the outside. So really what I added here was 18. 2 times 9 is 18, right? So the value that I added here was 18. That's the value I need to offset. So what should I subtract? 18. And that's the tricky part. So you add in b divided by 2 squared, but you subtract a times b divided by 2 squared. Right? You have to offset the value that you added. You added 18 here, 2 times 9. So you got to subtract 18. Does that make sense? Okay. Now, next step, now we're back into our normal steps. Combine your numbers. So I get y equals 2 times x squared plus 6x plus 9, and then minus 22. Now I can factor this. So I can either do it in 2 steps or 1, if you know how to just turn it into perfect square. So I would factor into perfect square. So this becomes y equals 2 times x plus 3, x plus 3 minus 22, right? Just b divided by 2 in each spot. And then I can turn that into vertex form by restating it as x plus 3 squared minus 22, okay? So last step is rewrite in vertex form. Okay, so that's the process. We're going to do one last example. You can see it doesn't always take as long when you're not writing every step down, right? And then I'll give you your homework, okay? Now, I should say, if this method is super confusing, that's okay. You have another method. This is a more efficient, quicker method, but you have negative b over 2a, plug it back in, find your y. You have that method still, right? So if on a test or something like that, I'm not going to say you have to do this method. You choose your method. But this is a quicker way, and when you're in advanced math, you want to know the most efficient way. All right, so here's our situation. Y equals negative 3x squared minus 24x minus 45. First step is kick out the c. Minus 3x squared minus 24x, leave a space, minus 45. Next step is, I'm not ready for perfect square yet because I have that. You got to factor out the negative 3. So y equals negative 3 times x squared plus 8x minus 45. Next step is, I got to put something right there. What do I put there? B divided by 2 squared. 8 is b, divided by 2 is 4, plus 16. Now, what's the net effect that I did here? Think. The net effect that I've contributed to this equation right now by putting that plus 16 there.
Negative 48.
I've done negative 48 damage here because there's a negative 3 here. So what's the opposite of negative 48? So I have to put a plus 48 out here. You always have to offset your damage, right? So I get y equals negative 3 times x squared plus 8x plus 16 plus 3. And now I just turn that into a perfect square. Y equals negative 3 times x plus 4 squared plus 3. And I have vertex form. And it's a lot easier than negative b over 2a. Well, I shouldn't say easier. Quicker, more efficient than negative b over 2a because you didn't have to deal with all that. Right? Okay, so remember, we're hoping to turn this into intercept form, which would be y equals a times x minus p, x minus q. Right? We want to get it to that. We want y equals some parentheses times each other. Right? That's what we're going for. We talked about how you can use the magic x to get there, but we also talked about how if you have, to use the magic x, your best case scenario is if?
They go into each other.
Yes.
Well, what do you mean? To use the magic x, something has to be true.
They must multiply? No.
What do I need to do first before I can use magic x here?
Divide by 2.
Divide by 2. Because I want the a to be 1.
No, yeah.
That makes magic x really easy. Okay? So, we have to get a to be 1. So before we can do this whole thing, we need to say, let's get the a to be 1. So typically, so this is what we're going for. So typically, the a value is usually your GCF. So you want to check that, see if it is, right? Can everything here be divided by 2?
Yeah.
Yeah. So I'm going to pull out a 2, make big parentheses, and then divide everything by 2. 2n squared divided by 2 is just n squared. Negative 16n divided by 2 is negative 8n. And 24 divided by 2 is 12. Now, I want to focus in on this red equation, right, in the inside. Because that's what I can now magic x, because that doesn't have a number in the front. So, I'm going to magic x that. I say, okay, 12 on top, minus 8 on the bottom. Two numbers that multiply to give me a positive, but they add to give me a negative. How's that possible? Has to be two negatives. And then what two negatives multiply to give me 12, but add to give me 8? 6 and 2. So I take those and I plug them right in. I get y equals 2 times x minus 6, x minus 2, right? And guess what? I have intercept form. I'm done. I got the thing I was trying to get, right? Trying to get that, and I have it. Done. Okay, I'll check in a second. All right, so that was number 3. Now, let's look at number 2. Number 2. This homework was a good example of why, if you're doing a homework problem and you're like, I can't break this one, you look at the answer key to give you a little bit of a head start, because you might have been closer than you think here. And you'll see what I mean. Okay, so I got y equals 5k squared minus 35k minus 70. Again, that same thing. I want to say, I want a to be 1. I don't want this 5. So I'm going to try to pull that 5 out. Y equals 5, big parentheses. And then I just divide everything by 5. If I do that, I get k squared minus 7k minus 14. Okay? Now I take that to magic x, right? I go, okay, well, I got minus 14 on the top and minus 7 on the bottom. So I need to find combinations that multiply to give me 14, negative 14, and add to give me negative 7, right? So this is, sometimes it's really easy. You're like, oh, it's boom and boom, 6 and 2. Sometimes you just can't get there. If you just can't get there, you got to eliminate all your possibilities, right? So you take the number on the top, and you say to yourself, well, what are all the combinations that multiply to give me 14? 2 and 7. What else? 14 and 1. Anything else? No. So it's got to be some combination of here if this is going to work, right? So I know I'm multiplying to get a negative, so what must be true? One's negative and one's positive. And now I check all my combinations. There's 4 possibilities here, right? Let's go through them. Negative 2 and positive 7. Does that give you a negative 7? No. Negative 7 and positive 2. Does that give you a negative 7?
No.
Negative 14 and positive 1. Does that give you a negative 7?
No.
Negative 1 and positive 14. Does that give you a negative 7? No. So what does this mean? We don't go to decimals. It's not undefined, but this didn't work. It's already in its simplest form. Remember I said that some equations can't be in intercept form? Remember there's situations where you can't do intercept form? Sometimes that's the case, okay? And that's what this problem was designed to prepare you for, right? So this is what's considered fully factored, meaning you factored it as much as you can. You can't factor it further. You can't pull anything out. You can't chop it into pieces. It is fully factored, and that's your final answer. Your instructions said factor each completely. Well, this is factored completely. You can't do anything more with it. Okay? Make sense? Now, what's tricky about these is when you get one of these that you can't do, you sit there and you think to yourself, is this one of those times where you can't do it, or I just don't see it? I just can't. So that's why we look at all the combinations, and then we check each one. And once you do that, you can feel confident this is one of those times where it doesn't work. Okay? Now, The other thing is when we start solving these further, there is somewhere we can go with it. It's that crazy equation over there. But we're not there yet. Right? We're not there yet. Okay, so next one we wanted to talk about was 5. So number 5, when you don't, here's a rule, right? When you don't have a C, it's a very good chance you have a GCF. That's a letter. Okay? When you don't have a C, well, think about it. If I don't have a C, what must go into both of these? X, right? X squared and bx, or ax squared and bx. That's always going to have an x go into it, right? So that's my GCF. So that's what I pull out. And I divide by x, and I divide by x, excuse me, and I get x and plus 4. And guess what? That's intercept form, right? I know intercept form usually has 2 parentheses, but really what this is x plus 0 and x plus 4, and then x plus 0 simplifies to x. So you're done. You didn't even need the magic x on this one. Okay? So if you're missing a C, you can think this. Okay? All right. Now we move to 8. All right, 8's already got an A of 1, so we can go straight to magic x. Right? I say negative 20 and 5. 2 numbers that multiply give me negative 20, add to give me 5. So I go, I can't see it. So I go, well, 20. What multiplies to give you 20? 10 and 2. Anything else? 5 and 4. Anything else? 20 and 1. Okay. I got a negative, so it must be a negative and a positive. So let's check them out. I'm trying to get 5 here. Negative 10 and positive 2. Negative 2 and positive 10. Negative 5 and positive 4. Negative 4 and positive 5. Negative 20, positive 1. Negative 1, positive 20. No. So this didn't work. So it turns out this is fully factored. It's not factorable further. Okay? So if you did this and you were like, God, I can't figure it out, right? But then you were like, well, let me check the answer key. I'm not cheating. I tried here. You would have seen it said not factorable, right? It's fully factored, okay? So use that tool to help you. Okay. Any other, question? Yeah, sure. So number 7. Whoop. Number 7. Okay. So remember, the first thing you always want to look for is a GCF. I know that this is a weird looking one, but still we want a GCF first. Does anything go into 4m squared and 100? 4. Yeah. 4 goes into both of those. And I get m squared minus 25. Okay, I'm going to tell you a couple things here. The first is, if you're missing a b, what can you put in its place? 0. So you can go 4 times m squared plus 0x minus 25, and now you can magic x this, right? You can say, okay, I got minus 25 on the top and 0 on the bottom. 2 numbers that multiply to give me minus 25. It has to be a minus plus situation, and they add to give me 0. Negative 5 and 5. It has to be the same number if it's adding to give you 0 and it's a positive and a negative. So that means I have 4 times m minus 5, m plus 5. Now, I'm also going to introduce you to something that we haven't talked about yet, that we will talk about, but I might as well tell you about it now. This situation here, m squared minus 25. Okay? This is called the difference of perfect squares. M squared is a perfect square. 25 is a perfect square, meaning you could square root both of those and get an answer. And the minus is a difference. So it's a difference of perfect squares. Whenever you have a difference of perfect squares, you get the square root of both, so m5, m5, and minus plus every time. Okay, just a little shortcut. And we're going to talk about that in a lesson. But hey, we got it here. We might as well talk about it. Okay? All right. Any other questions on the homework? 6. All right, so what's my GCF here? What goes into everything? -1, right? So I pull out a -1, and I get x squared plus 12x plus 20. Now I have that magic xable situation because a is +1. So that's 20 and 12. Two numbers that multiply to give me 20, add to give me 12. 10 and 2. So this is negative x plus 10, x plus 2. Okay? You could put a -1 out front. I wouldn't take off, but this is simplified. Okay? Are we ready to go to the notes?
Yes, sir.
All right, go ahead and get your notes out.